Here we go. One more shortcut we're going to see if we can figure out by doing the problem the long way. So here we've got four problems, and what you'll notice about these, they're all once again division problems or quotients. And each quotient or division problem has been put in parentheses and put to a certain power. And so once again, we want to think about what this looks like the long way. So let's take a look at this first one here. Now we've got 2 over x in parentheses to the third power, which is basically saying whatever's in the parentheses is being multiplied times itself 3 times. So we could write this out like this. 2 over x times 2 over x times 2 over x. But the parentheses are just another way to say multiplication, so we could also simplify this down to just this. In which case, on the top, we've got 2 times 2 times 2, which is 2 to the third power, over x times x times x, which is x to the third power. And since we know what 2 to the third power is, we'll make that 8 over x to the third power. All right, and so we figured out that 2 over x, parentheses, to the third power becomes 8 over x to the third. So do like we've done so far this whole unit, which is now take the next one, write it out the long way, see what you come up with, and then see what you can do about coming up with a shortcut that can take you from here to your answer and skipping all the work. So let's take a look at this next one. We'll get it started for you. Once again, we've got m to the third power over n to the second power, the whole thing to the fourth power, which means this is just going to get repeated 4 times. All right, so see what you can do. Take it from here. Think about what this would look like without the parentheses, and then try to multiply it all together and get a simplified answer to what we have here. Okay, so let's see if you and I came up with the same thing. So if you take a look here, here's all the finished example problems done the long way. Our first example we had done already. We got 8x to the third. And this is the one we left you off on. M to the third over n to the second, the whole division problem or quotient to the fourth power, written out the long way, then becomes m to the 12th over n to the 8th, because here m to the third times n to the third times n to the third times n to the third. We talked about this shortcut a couple lessons back where you're multiplying with exponents, you actually add them. Same thing on the bottom here. N to the second times itself 4 times. The shortcut is to actually add the exponents, so n to the 8th. And if we apply that to the rest of the problems, we get these. G over h to the third, the whole thing to the second power becomes g to the second and h to the sixth. Finally, we get 5s over r to the third, the whole thing to the third power. We eventually get 125, s to the third, r to the ninth. And so hopefully what you came up with is this concept that much like putting a multiplication problem to a certain exponent, that we can put a division problem to a certain exponent, and we get this rule. When raising a quotient or a division problem to a power, all the parts of that division problem get raised to that power. And if we say that algebraically, we get this. A divided by b, the whole thing in parentheses to the power of n, equals a to the n over b to the n. And so this is how we deal with putting a quotient or a division problem, the whole thing, to a power. So now if we apply it to a problem like this, we can now use that shortcut to speed up the process. So what we would do here is, for example, number 1, we've got x divided by y, the whole thing to the fourth power. We essentially just make sure that that exponent ends up attaching itself to each part of the problem. So here we would get x to the fourth, and then y to the fourth. Now the only thing you have to be careful about is realizing how many parts there are to a particular problem, like this one. 2m divided by n, the whole thing to the fifth power. But if I really think about the inside, it's 2 times m divided by n. So there's actually 3 different parts to this division problem. So the 2 to the fifth power we need m to be put to the fifth power, and then we need the n on the bottom to be put to the fifth power. So it looks something like this. 2 to the fifth power times m to the fifth power over n to the fifth power. Every single part inside gets that power. Now here, 2 to the fifth power, we can take that further. Turns out 2 to the fifth power is 32, so we'll simplify it further, and then just rewrite the rest. So there we go. So the key here is when you give that power to each part of your quotient, just make sure you're doing it, all of it. So like right here, hoping you're looking at this and you're seeing 4 different parts. R to the second, S, 3, and T to the sixth. So if I do R to the second to the fourth, that's kind of like that double exponent shortcut we talked about. R to the second to the fourth, a power to a power. Shortcut is to multiply them together. So we get R to the eighth. Then we do S also to the fourth power. So S to the fourth. Down below we get 3 to the fourth power. And finally we get T to the sixth to the fourth power. And again, just like at that beginning part, we've got a double exponent here. So T to the sixth to the fourth. Shortcut is to multiply the exponents. So we get T to the 24th. And we've got a normal number down here, which we can clean up further. 3 to the fourth power turns out to be 81. So what I get as a final answer is R to the eighth, S to the fourth, 81, T to the 24th. And so this is how you take a quotient or a whole division problem and raise it to a certain power. All right, so take a look at the next problems where we'll apply this to some trickier problems and see what you come up with.